Beneath the serene landscapes of Yellowstone National Park lies one of the most powerful geological forces on Earth. A supervolcano capable of unleashing catastrophic eruptions with global consequences. Yellowstone's vibrant geysers and hot springs, beloved by tourists, mask a colossal magma chamber that has shaped the planet's history and could do so again. Recent scientific observations have detected subtle but unsettling changes. Small tremors, ground deformation, and increased geothermal activity that raise a critical question. Is Yellowstone's supervolcano awakening? This article delves into the true scale of Yellowstone's geological might, its historical eruptions, the signs scientists are monitoring, and the potential implications of a future eruption. While the likelihood of a catastrophic event remains low, understanding this hidden giant is essential for grasping both its awe-inspiring power and the scientific efforts to predict its behavior. Yellowstone National Park, spanning parts of Wyoming, Montana, and Idaho, is renowned for its geothermal wonders. Old Faithful's predictable eruptions, vibrant hot springs, and bubbling mud pots. These features, however, are mere surface expressions of a far more formidable system. Beneath the park lies the Yellowstone Caldera, a massive volcanic depression formed by ancient eruptions. Measuring approximately 45 by 30 miles, 72 by 48 kilometers, this caldera is one of the largest in the world, dwarfing the visible landscape above. Unlike traditional cone-shaped volcanoes like Mount Vesuvius, supervolcanoes like Yellowstone are characterized by their vast collapsed craters, formed after massive eruptions empty their magma chambers, causing the ground above to collapse. The Yellowstone caldera is not a single volcano, but a complex volcanic system, often described as a hot spot where molten rock from deep within the Earth's mantle rises toward the surface. This hotspot has been active for millions of years, leaving a trail of volcanic activity across the western United States as the North American tectonic plate moves over it. Today, the caldera's geothermal features, geysers, hot springs, and fumaroles, are powered by the heat of this underlying hotspot, serving as visible reminders of the restless giant below. At the heart of Yellowstone's supervolcano lies its magma chamber, a sprawling reservoir of molten rock that fuels its geothermal activity. Seismic imaging and geophysical studies have revealed that this chamber is immense, extending up to 60 miles, 100 kilometers across, and containing an estimated 10,000 to 15,000 cubic miles, 41,000 to 62,000 cubic kilometers, of molten material. This is thousands of times larger than the magma chambers of typical volcanoes, earning Yellowstone its supervolcano designation, reserved for volcanoes capable of erupting more than 240 cubic miles, 1,000 cubic kilometers, of material in a single event. The magma chamber is not a single pool but a complex system of molten and partially molten rock, interspersed with crystal mush and gas. It sits between 3 and 9 miles, 5 to 15 kilometers, beneath the surface, with a shallower upper chamber connected to a deeper reservoir. The heat from this magma drives Yellowstone's geothermal features, but it also poses a potential hazard. If enough pressure builds within the chamber, it could trigger an eruption of unimaginable scale. While such events are rare, the sheer volume of magma underscores why Yellowstone is one of the most closely monitored volcanic systems in the world. Yellowstone's supervolcano has erupted 3 times in the past 2.1 million years, with each event leaving a profound mark on the planet. The most recent major eruption, known as the Lava Creek eruption, occurred approximately 640,000 years ago, forming the current Yellowstone caldera. This eruption ejected about 240 cubic miles, 1,000 cubic kilometers of ash, rock, and lava, blanketing much of North America in ash and altering global climate patterns. Evidence of this eruption has been found as far away as Nebraska and Texas, with ash layers preserved in geological records. Earlier eruptions occurring 1.3 million and 2.1 million years ago were even larger. Smaller eruptions and lava flows have occurred more frequently, with the most recent volcanic activity about 70,000 years ago. While these events were less catastrophic, they highlight Yellowstone's ongoing activity. The geological record shows that supervolcanic eruptions occur roughly every 600,000 to 800,000 years, placing the current time uncomfortably close to the interval since the last major eruption. However, scientists emphasize that volcanic systems are not strictly cyclical, and an eruption is not overdue in a predictable sense. One of the primary ways scientists monitor Yellowstone is through seismic activity. The region experiences thousands of small earthquakes each year, most too minor to be felt but detectable by sensitive seismometers. These quakes are often caused by the movement of magma, fluids, or gases beneath the surface, offering clues about the volcano's behavior. In recent years, researchers have noted occasional earthquake swarms, clusters of small quakes occurring over a short period. For example, a swarm in 2017 included over 2,400 quakes in a few months, though none exceeded a magnitude of 4.4. While these swarms are normal for an active volcanic system, they draw attention because they could indicate changes in the magma chamber, such as increased pressure or movement of molten rock. Scientists at the Yellowstone Volcano Observatory, YVO, a collaborative effort between the U.S. Geological Survey, USGS, the National Park Service, and academic institutions, analyze seismic data in real time to assess whether these patterns signal a potential escalation. Another key indicator is ground deformation, the subtle rising or sinking of the Earth's surface caused by changes in the magma chamber. Yellowstone's caldera is known to breathe, with periods of uplift followed by subsidence. GPS stations and satellite-based radar, INSAR, have measured uplift rates of up to 2.8 inches, 7 centimeters per year in some areas, particularly between 2004 and 2010, when the caldera rose significantly. Since then, the ground has subsided slightly, but recent data show renewed uplift in certain regions. This deformation is thought to result from the injection of magma or hydrothermal fluids into the chamber, increasing pressure. While these movements are not necessarily precursors to an eruption, they are closely monitored for unusual patterns. For instance, rapid or sustained uplift could suggest significant magma movement, prompting heightened scrutiny. Yellowstone's geothermal features also provide critical data. Changes in geyser activity, hot spring temperatures, or gas emissions can indicate shifts in the underlying system. For example, increased emissions of carbon dioxide, helium, or sulfur gases could suggest magma rising closer to the surface. In 2018, Steamboat Geyser, one of Yellowstone's largest, began erupting more frequently after years of dormancy, sparking interest among scientists. While such changes are often part of natural variability, they are meticulously studied for anomalies. The YVO uses a network of gas sensors and thermal imaging to track these indicators. Hydrothermal explosions, smaller events caused by steam buildup, are also monitored, as they can occur without warning and reshape the landscape, though they are far less destructive than a supervolcanic eruption. A full-scale supervolcanic eruption at Yellowstone would be a rare and catastrophic event, dwarfing any volcanic disaster in recorded history. Such an eruption could eject enough ash and gas to blanket North America, disrupt global agriculture, and cause significant climate cooling for years. The immediate impact zone, within a 100-mile, 160-kilometer radius, would face devastating pyroclastic flows, fast-moving currents of hot gas and ash, capable of destroying everything in their path. Ashfall would extend thousands of miles, with deposits potentially rendering farmland unusable and disrupting transportation, water supplies, and infrastructure. Despite these dire scenarios, the USGS and YVO estimate the probability of a supervolcanic eruption in any given year as extremely low, on the order of 1 in 730,000. Smaller eruptions or hydrothermal explosions are more likely but far less catastrophic. Scientists stress that there are no current signs of an imminent eruption, and any significant activity would likely be preceded by detectable precursors, such as intense seismic swarms or rapid ground uplift. Preparedness efforts focus on monitoring and public communication. The YVO issues regular updates, and contingency plans are in place for localized hazards like hydrothermal explosions. In the unlikely event of escalating activity, evacuation plans and ashfall mitigation strategies would be implemented, though a full-scale eruption would pose unprecedented challenges. The Yellowstone Volcano Observatory exemplifies the power of scientific collaboration. Equipped with advanced tools, seismometers, GPS, gas sensors, and satellite imagery, the YVO provides real-time data to researchers worldwide. Citizen science also plays a role, with park visitors encouraged to report unusual activity, such as changes in geyser behavior. This comprehensive monitoring ensures that any significant changes would be detected well before a major eruption. Research continues to refine our understanding of Yellowstone's system. For example, recent studies have mapped the magma chamber's structure in greater detail, revealing its complexity and informing eruption models. International collaboration also allows scientists to compare Yellowstone with other supervolcanoes, such as Toba in Indonesia or Long Valley in California, to better predict potential outcomes. Yellowstone's supervolcano is a testament to the Earth's raw power, a geological marvel that captivates and humbles us. While its potential for global disruption is real, the likelihood of a catastrophic eruption in our lifetime is vanishingly small. The subtle signs of activity, earthquakes, ground deformation, and geothermal changes, are part of Yellowstone's natural rhythm, not necessarily harbingers of doom. Through vigilant monitoring and cutting-edge science, researchers are unraveling the mysteries of this hidden giant, ensuring that we are prepared for whatever it may bring. For now, Yellowstone remains a slumbering giant, its beauty and power a reminder of the dynamic planet we call home.